Hello, guys. We're still working, still grinding these Leetcode questions. Question being asked by Apple, Microsoft, and Amazon. Right. This is search in a binary search tree. Very easy question. So basically, you have been given a binary search tree, and then we want you to return. Right. The question is going to give you a file, right, or the node value. And then once you get that node value, well, we want to return its return that node and its subtrees, basically, right? So basically, um, um, we have for the first example, right, we have this tree, and then we have our val. Our val is equal to 2. So now we want to return 2 and its subtrees. So basically, how do you return 2 and its subtrees, right? You don't have to do any building. Once you just get 2, you can say, okay, return let's see, 2 becomes root, right? So if root is equal to 2, right, you return root. And when you return root, it will, return its subtrees, basically. Right. So we do this for here. We search in our binary search tree. We do not find 5, right, which is what the question is giving us. So what we want to return is what? Something empty, which is null, right? So basically, easy question. How do we, go about searching a binary search tree? Well, in a binary search tree, right, every root that you have on its left side, you have elements that are strictly less than your root, right? And on the right side, they are strictly greater than the root. So say, for example, my root is 4, right? I know to go on the left side because I know every element that we are having on four's left side should be less than 4, right? So then if I'm looking for 2, I come here. Now if I came here, maybe I was looking for 3, right? I'm on 2. I know what 3, because you know 3 has to be on the left side of 2, basically, right? So I will come here, if you get what I mean. So basically, the binary search tree is just like that. Depending on the value, right, you know whether to recurse on the right or the left, right? So how do we, code this out? Basically, we say that if the root is equal to null, right, then we want to return null, right? An empty tree, just return null all the time. And if not, what we want to do is have a function. I'm going to call it DFS, and I'll give it the root and the val, right? And then after that, what I want to do is actually with our DFS, what I want to do is what return the tree node, right? So basically I'll return DFS. So basically our DFS should give us what a tree node. So the DFS you have tree node and it's a root and an int file, right? And I will say that if the root is equal to null, right, then return null. So basically we hit the termination point. If not, what I want you to do is to say that now if the root is not equal to null, right, and that the root value is the same as the value that we are interested in. If it is, then all I want you to do is what return root, as I previously said, right? So, um, if not, what we want to do is what then recurse on our left or our right, to find what we are looking for, right? To find like let's say we are looking for 2, right? Then we know to what recurse on the left, or if you are looking for something else, right? Then we recurse on right. So say that if val is less than our root of val, right? If it is less, right, then we want to check on the left side. So we'll say return what DFS, and I'll give it root dot left, and I'll give it our val, right? So basically, it's going to go on the left side if our val is less than the current root that we are dealing with, right? If not, what I want to do is say else it should was return our DFS on the root dot right, and then val. Just trying to knock these questions out. Right, pass first 2 test cases, and then yay, pass 100%. So guys, O of n, right? What's the space? Sorry, the time complexity O of n, right? We're going to touch every node. Actually, we might not touch every node, right? But in the worst case, we will. Basically, like if our tree is like super unbalanced, it's like a linked list, right? Let's say 4, 7, and then it keeps going with only elements that are greater than, and then we go find the last element. If it's balanced though, right, it shouldn't be. It should be like log n, I think. So, um, without further ado, guys, I want to see you guys on the next one. Send me any questions that you want me to, solve for you, or at least look at and try and explain. I'll see you guys on the next one. Peace.